A bitmap is a long string of bits, ones and zeros, where ones means a true value and zero means a false value. And this is the most optimal way of storing an array of Boolean values. That can be, for instance, the pixels inside of a image file, or it can be something like a memory allocator, where each bit means a block of memory that has been allocated or not. For instance, there are many uses, and let's create this thing. Sup guys, welcome to today's show. So let's code a bitmap in C, shall we? I have started this project with just some type definitions for integer types and some macros for typecasting, and then I have a clean .c file right here. Alright, so we're gonna use int8 as the basis. Let's create a constructor function for the bitmap. So let's first say int8 is the bitmap, right? And our constructor, so it's going to return a bitmap pointer. So make bitmap BMP, and the only argument is going to be the number of bits that we want to use. And in this case, I'm gonna use int16, but you can make it bigger if you like. So the general idea is we call make bitmap with 14 bits, and it will create the proper sized bitmap for that. So this will be 2 bytes in this case, right? 8 bits per byte. And I also want to have a zero function which will clean out a data structure. So void zero, it's going to take destination source int16 for a size. Alright, so let's start by creating this zero function real quick. So we have a destination, we have a source, we have a size. And we need some pointers, right? Wait a minute. We don't really need a source because we are not copying anything. We are just cleaning it out, right? Well, this is what it should look like. Alright, so let's create a pointer. Let's create some integer counter. We set the p equal to the destination, the n is equal to the size. As long as we have a size, we iterate, and we want to minus the n and plus the p for each iteration. Alright, so welcome back. So at each iteration we want to set p to 0. And that's basically it, right? I think that is good. Okay, so we have a zero function. Let's create the constructor. It's got to be a fairly simple thing. So we return a bitmap pointer. We want to have a size in bits, and we need to convert it into a size in bytes, which we do by just taking bytes equal to 2 bits divided by 8, right? but then we need to plus 1. And why plus 1? Well, let's say that we want 5 bits. So this will be 5 divided by 8, which is 0, since we don't have any decimals here. And we want, in this case, with 5 bits, we want 1 byte, right? So 1 more. Let's also create a pointer for the return value. And we need, let's see here. This is all we need. So let's allocate for this. We can call malloc with the integer version of the number of bytes. And we zero out p with the int 8 version of, no, int 2. It was because this is 16 int bytes. So this will zero out the thing. Now that we have zeroed it out, we can simply return this. We return p. Okay, easy peasy. Let's just see that everything compiles this far. We don't have malloc. So we need unistd, right? Or is it stdlib? Stdlib. Okay, that's good. So what is the logical next step? Well, we need to be able to get a specific bit. So if we run get bit and we provide the bitmap, and we want to say that we want bit number 15, we want to return true or false. So we need to first figure out which byte this bit is in, and then we need to mask out that bit so we can extract it. And then we need to push around the bits a little bit so we get it in the right position. So let's start with its signature. We are going to have a bool, which means that we need another include. So we return a bool, get bit, we provide a bitmap pointer, and we will specify an int 16 with the bit number. Okay, so let's visualize this so it makes it a little bit easier. So let's say that we have, I don't know, this is 1 bit, this is another. So if we want bit number 0, it's this, right? And bit number 3 would be 1, 2, 3, this. And bit number 8 will be this. So first we need to figure out which byte we're in, and then we need to take care of the rest. So we will have a bool get bit of bitmap pointer bmp int 16. This is the let's call it the bit number. And we need to have the byte So let's see. Let's call it the byte number as well. And then we need the actual byte, and we need the actual bits. Yeah, something like that. Okay, so first off, which byte are we going to go to? So we need to do basically the same as down here. We take the bit number and we divide it by 8. So if we have bit number 3, we're going to have a 0 as a result. And we want to access byte number 0. So we can just do it right off with a division. So the byte number is going to be equal to the bit number divided by 8. Okay, so let's say we have bit number 9, and these are from 0 to 7, so this will be 8, 9. We want this specific bit, and we have located the byte number, so we are inside of this now. And we need to figure out what position that is in. So if we take the modulus of bit number modulus 8, so if we have bit number 9, and we divide it by 8, we get 1. So that's this byte, right? If we take 9 modulus 8, then we will get, let's see, if we have 8 modulus 8, it would be 0, so 9 is 1 more than that, so this will be 1 in this case. So this is bit number 0 in this byte, and this is bit number 1. So that's going to work. So, alright, so let's create another int 8, and let's call it bit position. So this will be the relative position inside of the byte that we find. So the bit pos is equal to bit number mod 8. So now we have the index, and we can extract the actual bits. So let's see, let's start by getting the byte. So we go to the bitmap at index byte number. All right. So now we have this inside of byte, and we want this 0 right here. So what we need to do is to mask it out. So we need to create a byte which has all zeros but a 1 for the one that we want. Okay, so what we can do is we can start out with just a regular 1 like this. Then we push it to the left a number of times. So if we push it 0 times, we're at bit position 0. If we push it once to the left, which we want to, and it will fill up with zeros on the right side, then we need to push it one step right. So basically we can say that the bit is the let's create one for the mask as well, just to make things real clear here. So the mask is equal to a 1 pushed left bit pos number of times. And now we have that mask like this. We want to do an AND operation between these two, which will result in either, if it's a 0, as in this case, we will get 0 back. Otherwise, we will get that 1 at that position. So we will do the AND operation, and then we want to push it back to the right, so we get it at the right position. So we want to push it as many times as we push left, we want to push it right, and it will fill up with zeros, and we will get the result here. So the bit is going to be the byte ANDed with the mask pushed right bit pos number of times. And if this is positive, we return true, otherwise false. And this will be our final return value as well. Alright, so let's try this function out. So let's say we have a bitmap BMP. We set it to make bitmap, and let's say 16 bits. By the way, let's do one check as well. So in this constructor, if the malloc fails, so if we don't have a P, in that case we want to return a bitmap pointer of 0 to indicate the error. And then we can do the same down here. Let's just do if we don't have a bitmap, we return right away. Alright, otherwise we do have a bitmap. So let's temporarily just set 1 bit inside of it. Because we don't have the set function yet, but let's say that we can take the same example as we had. So we have the BMP plus 1, and I set this equal to well, let's say 0. And then we can do something like so bit, what was it, 9 I think, is equal to, and then we have let's do it like this. So we run get bit, of BMP 9, and if it is true, we will return a 1, otherwise 0. Then we free BMP, return. Alright, so in this case it should definitely return 0. Did we not use the byte number? Byte number. Byte number is bit number divided by 8. Well, we have it here, right? Oh, bitmap of this should be BMP of. That's probably why. Right, I casted the wrong way, didn't I? So this should be, let's see, byte is it's a single intake. Okay, let's do this then. I don't have a macro for that. Okay, compiles. Bit number is 0. Maybe we should add a new line here as well. Like so. Okay, so what if we do have something there? So if we were to set this byte to 2, 2 means 1 0 in binary, which would set the 9th bit. So in this case we should get a 1, right? And we do. It works. Pretty nice, pretty nice. Alright, so now we can get the bit. Let's set the bit. So, what will be the signature? Well, we don't really need to return anything, do we? No, we don't. So this will be a void set bit. We will have a bitmap and a position and a bool. Are we going to set it to true or false? 1 or 0? Alright. So void set bit, we have bitmap, BMP, we have int16 bit number, and we have bool val. So let's see, can we utilize our getBit function here? We should be able to, right? By the way, we should make sure that we have a bitmap, because if we don't have a bitmap, let's say we return false in that case. Alright, so let's do the same check here. If we don't have a bitmap, we should not do a silent return here, really, but I don't want to mess too much with error handling now. You know how to deal with that, right? Okay, so we still need to know what the byte is. Well, we basically do need to do a lot of this stuff. So let's copy this. And let's remove what we do not need. So here we extract the bit. We don't really need to extract the bit because it doesn't matter what its current value is. We only need to set it no matter what. So we don't need to do that. We still want to find the right byte. We want to mask out let's see here. I need to visualize this. So let's say we have something like this. We want to set bit 1 to a 1. And we have created a mask which looks like this. Which we can use if we wish to set the bits, because then we can OR it with this value and it will be set. Alright, so if val is positive, in that case we want to set the mask to this. And we want to have a value, let's see here. We want to have a variable for the new byte. So in this case it will be easy. The new byte is going to be equal to the current byte ORed with the mask. So this will set the bit. But if we want to unset the bit, then we want to create an inverse mask which has all ones except the one we want to remove. And then we want to run an AND operation which will unset the bit. So mask is going to be the same, but it's going to be the inverse. And the new byte is going to be the byte ANDed with the mask. This will unset it. And now that we have the new byte, we need to insert it into the bitmap. So the BMP at byte number is going to be equal to the new byte. And then we can say to return. Alright, so let's see if this works. Now instead of using this, we can just set the bit of BMP at position 9 to true, which means in this case it's going to return 1. Return with a value 16. That is true. This should only be a return, and we can remove the duplicate. This should be a semicolon. And now I believe it's going to compile. No? 29. Right. Okay, yeah. We're only going to return not with a value. And now it's going to compile. And do we get a 1? We got a 1, ladies and gentlemen. So let's see if we can unset it afterwards. So first we set it, and let's also set, I don't know, bit number 10 to true, and then we unset bit 9, and we want to see its value. So now we should get a 0. Which we do. So we have successfully created a bitmap construction in less than an hour. So I really hope you liked this episode. Please like and subscribe. Thanks for watching. Thanks for tonight.